This question, we have a graph, so the first thing we're going to do is analyze the graph. Origin, y-axis, x-axis, the things we can read, the slope, the gradient of the slope, and the area. The origin is a straightforward first quadrant. Y-axis is force in normal units. X-axis is time in normal units, so therefore any questions about force and time would simply be read off the graph. The slope is delta F over delta T, which is the rate of change in force. And the area is F delta T, which is, by definition, the impulse. And that happens to be equal to delta P, which is equal to M delta V. Now, we do notice that the force appears to be constant, about a constant 3 newtons. So now we understand this graph, we can read the question. Which the object travels across a horizontal surface for 2 seconds. There's a net force applied to a 2 kilogram object. That's the first bit of information we haven't used. With a speed of 0.5 meters per second. So we have an M and we have a V0. Used to create the graph. All friction is negligible. The graph known data to determine the momentum of the object after the force was applied. Well, let's see. We know the momentum beforehand is mass of 2 kilograms times 0.5, which is 1 kilogram meters per second. And we know the change in momentum is the area. And the area of this graph for 2 seconds the area is equal to 3 times 2, which is 6. So the change in momentum is 6. Delta P is P minus P0. We want to know the instantaneous momentum or the momentum afterward. Well, that would be delta P plus P0. So we have a change in momentum. That is equal to 6, and we know it's positive 6. The initial momentum is the mass times the velocity. We are given the speed, which is 0.5, which means the velocity could be either plus 0.5 or negative 0.5. So the momentum is either positive 1 kilogram meters per second or minus 1 kilogram meters per second. Now, the force, it doesn't say if the force is applied in the direction that it's traveling. So if we say the object is traveling in this direction, and that's the positive direction, and that's the negative direction, we aren't told if the force is with it or the force is against it. So it appears at first we could say that this is true. We could have 7 kilogram meters per second, or we could have 5 kilogram meters per second. So can we determine the momentum afterward? The answer is no. No, because the data is too scattered. That's not the reason. That's false. No, because the student needs to know the direction that the force is applied to the object, because the applied force will be in the same direction as the change in momentum of the object. And that's why we are at the last choice.